Welcome to the Theosophical Society. Our Sunday lectures feature a variety of topics in those areas related to the esoteric sciences.
Oh, thank you.
This discussion is being recorded by the Atlanta Forum Network. Let's take a moment and listen to this benediction. Out of the vast totality of objects ever present in the universe, the mind perceives only those which conform to the hue of its karma. The rest remain unseen, even though close at hand. That's from Patanjali. If you or someone you know would like to present a lecture, please see Brian James and he will be happy to help you. Our guest speaker today is Dr. P.V. Rao. He'll be giving a discussion on physics, philosophy, and spirituality. Dr. Rao is an associate professor of physics at Emory University. He has done many lectures and classes on the interaction between science and religion. Dr. Rao will discuss the scientific worldview derived from the progress, science and physics, its parallels within the faith traditions of both the East and West. The exploration of these ideas has led to fundamental questions about what is real, true, good, and beautiful. In the exploration of those questions lays the bridge that connects both science and spirituality. Please give a warm welcome to Dr. Rao.
Thank you. I'm glad there's a blackboard here. My profession is wandering in front of a blackboard, and of course facing the students most of the time. The title looked very interesting because that is exactly the title I gave to a course which I teach it. You want this mic? Can you hear? Oh, okay. Okay, if I walk here and speak, can you listen to me? Just for fun of it. Okay. So the title actually is the title of a course which I give to undergraduates. But I have about 14 weeks or approximately 40 hours of classroom discussion to cover the topic there. Here in about 40 minutes or so, or 50 minutes, I'll have to tell you what I usually tell the students. Okay, that's the idea. Now I was thinking, as I was preparing the last few days, how to approach this subject in front of an audience of whom I know nothing. Where you are from, what your professions are, what background of information you have. So in the classroom, I assume they come from high school, they know certain things. I don't have to spell out the definition of everything they tell them. So usually that is the case in any public presentation. But I'm not going to ask you what your background is today, or how much physics you know. I will assume that you have normal acquaintance with the ideas that are floating around in this universe, let us say, much larger than us. In fact, if I were to be very clear and meaningful to you, I must really tell you what I mean by physics, philosophy, and spirituality. These are the key words in the title. Of course, they come, I just noticed, those are the words that come in the very first paragraph of Theosophical Society's goals. But I treat them now as human activities. Yes, there's a body of knowledge But that's what we do. Some are physicists, some are philosophers, some spend their time in spiritual quest. These are our activities. Some are deeply committed to them, some just look at it from a distance. When you talk of spirituality, it is useful to separate it from the broader concept of religion. When we use the religion nowadays, it involves the particular rituals, traditions, the organization, the authority, and all those things. Whereas I tell my students, when we talk of spirituality, we talk of the individual's quest for something larger than himself or herself, something transcendental, something beyond our reach, but maybe we can aspire to reach. Something unknown is there, maybe we have to understand that to live a better life. So in that sense, I will not be talking about each religious faith tradition's detailed use of the world. As a matter of fact, since my expertise in physics, I'll start with some physics. Philosophy, again, to define, is an attempt to answer some fundamental questions, some basic questions, like what is real, what is truth, why there is good and evil. I mean, if you go to a philosophy lecture or study philosophy, those are the kind of basic questions that you face. Of course, you narrow it down to specific cases and study. Ultimately, philosophers and people who are engaged in this state of spirituality, they all would like to ask the questions like, what is this universe like? What is the origin of the universe? How did it came about? Why are we here? What is our relation to the rest of the universe? Physics has specialized in understanding the physical universe. The way we live is related to the objects which we encounter, so we study seriously, or it provides us an opportunity to study the nature of the objects, how they are constructed, what is the matter made of, how do we all come together into being, the chairs and tables and beings. What was it like in the beginning? This is the way physics tries to reach the answers to these ultimate questions, but of course it doesn't claim that it has known everything. But it has developed a method which has become very successful. Successful in this sense, in understanding this universe, the nature, let us say. We have learned how it works. We were able to predict its behavior. We were able to formulate theories to describe how it works. In fact, we were able to invent things on the basis of our ability to predict, of course, based upon certain laws. That's what you learn since high school, college. Every physics course teaches you laws of physics. You don't have to just narrow it down to physics, chemistry, biology, including technology. All of this come under the same category. In fact, just look around the room. Everything here would not have existed, maybe except for the paper, 100 years before. Every object you see is made out of something we have understood and developed and modified to create this kind of a thing. And all of this is based upon our knowledge of how the materials work, how they are put together, what are the internal constituents. This is what the physics activity is. So in that sense, if you now put in your mind physics, philosophy, and spirituality, there are certain basic questions, fundamental questions, which all the three areas, three activities of the human being are involved. I could be, at the same time, a physicist, a philosopher, and a person who is spiritually oriented. And there are common questions and probably common answers. That's what. We like to find a complete, comprehensible view of the world that emerges from all these types of inquiries. But of course, what happens is, in practice, not everybody is a specialist in these three areas. Some become philosophers, some become physicists. So there is occasionally gap of communication, and of course there could be differences in the way you understand the world. So now I want to take the risk of actually telling you the story of physics in one particular area that has become fashionable nowadays to talk to. You heard the word quantum physics? Is there anyone who did not hear the word quantum? Everybody probably heard about it. I want to take you a very quick tour of what quantum physics means and how, with what extrapolations, we arrive at what we might call quantum spirituality, if you want to call it. I don't want to presume that you have read all the stuff which I have read. Probably not. Being a specialist, I might have read more than you. But the general ideas are now being talked about without actually, without the necessity of being an expert in quantum physics. General public is made aware of many of the aspects of the quantum physics in some fashion or other. But then the person who talks, picks the kind of things he likes to, or that which promotes his point of view. So let me briefly take you, and be patient. I won't teach you all the physics necessary to become a quantum physicist. What do I tell my freshman class to whom I teach quantum physics? You are all much wiser than my freshman class. Because remember, what we call quantum physics is a subject developed only in the last 100 years. Year 1900, probably no one talked about it. All that we know through this branch of quantum physics happened during the last 100 years. And most significant things probably happened in the first 2 decades or 3 decades. Of course, we are still learning more and more about the behavior of the world, or the behavior of the constituents of the world, the building blocks of the world, at the very microscopic level. We're not talking of interaction between trees and atmosphere, large, or baseballs, or people wandering around things. We are talking of the basic constituents out of which all matter is created. That's what we assume. We may not know completely, but we know definitely that the basic ingredients are, we might call them elementary particles, or if you want to learn the jargon, you call them quanta, whatever, these objects. I mean, you talk of electrons, neutrons, protons. These are already vocabulary you learn, you use them. You have machines that produce high energy electrons. Medical technology uses, these are almost real stuff. We know how to handle them. We don't touch them, we don't see them, but we actually produce them and use them. Our technology is dependent upon learning about the behavior of the elementary constituents. So, in order to understand the behavior of these elementary constituents, a mathematical theory was developed. in this mathematical theory, what we know about these elementary particles around that time, say around 1920s, what we know means by performing experiments, we understood how they behave in various situations. Experiment means you set up a particular environment and watch the objects do to us. We observe them, we have the pattern of their behavior understood, we codify them into laws of physics and all that. So having known that, a theory is developed to describe the most general behavior of these elementary particles. That's where the quantum physics starts. Now this mathematical theory starts by associating with any one of these elementary particles. We call it a system of particles or a single particle. We'll just use the word particle. The light particles, or light is also made up of particles. So we can think in terms of, when I say particle, we are talking of any of these small particles. A reactor produces neutrons. Those are elementary particles. Even though they are made up of smaller things, for our discourse, those are elementary particles. We can think of them. Now their behavior is encoded in a mathematical object. Maybe you heard the word wave function or psi or state vector. These are the code words which we use in developing this subject. So if there is a particle in a box, let us say it's a toy box, but I want to describe what this particle in the box is doing. So my mathematical theory, which is called quantum physics, associates with it a mathematical function. I'll just write that just for fun of it. Okay, everybody calls it a psi, so we use the word psi. It can be written in explicit form, which is not necessary now. It describes the state of the system, state of this particle for us. How do we know what the state of the system is? That is the theory. Quantum physics tells there is a way to find out how it looks like. So for that, a gentleman by name Schrödinger has prepared a procedure, a mathematical procedure. And you crank that mathematical procedure and you find out exactly how it looks like. But then what actually happened is, when you crank that mathematical procedure, you get not just one form, there are several. I just give them names, several of them, depending upon the particular situation. So when someone asks, what does that represent for us? What do you do with it? Oh, it's a good stuff. If you know that, for example, you can find out where the particle is in this box. You can calculate from it what is the energy of this particle. I'm just giving the basic example of how we build it. This is the philosophy behind this. If you can find such a mathematical object, and there is a procedure given to us by a person by name Schrödinger, and if he said, okay, you can get all these possibilities, but what does it mean? By applying a suitable formula, calculational method, you can calculate properties of the system by using these things. Okay? You are with me? You can make up your own story to tell what I am saying. But here is a mathematical way of describing a system, a microscopic system, in what all possible states it can exist. In what all possible states it can exist. If you happen to ask somebody a question, in what state it is, You can go through this procedure after training a skillful mathematician, find out all these things. But the theory says, interestingly, it could be in any combination of all these possible states. Instead of saying it is in this state, it simply says it is all in any possible combination of these states. Let me give a very pedestrian example. Let's pretend this is elementary particle, a pencil. By analogy I'm talking about. I'm holding, of course, with hand. Forget my hand. I can put it here, I can put it this way, I can put it that way, I can put it that way. There are several possible ways it could be oriented. Okay. I want all of you to close your eyes, maybe including the camera, which you cannot. Close your eyes. In what orientation this pencil is? Don't open your eyes. Can you tell me? I just tell you the story. It could be, you can open your eyes. If you are a brainwashed quantum physicist, if you believe in quantum physics, your answer should be, it is in a combination of all these possible states. I did not ask you to look at it. Just tell me, because you know all this knowledge, because you know the possible states it would be. When I particularly asked this question, your answer, correct answer according to quantum physics is, it is in a combination of all these possible states. Now that's, what do you mean by combination of all these possible states? But of course when you open your eyes, you know in which orientation it is. It's a horizontally oriented, let us say. You can tell specifically what it is. That means you interacted with the subject, saw what it is, that's called observation, interaction in the language. Then you actually find out in which state it is. Now, the metaphysical question. So if a microscopic object, before we observe, exists somewhere, what is the reality associated with it? Can we ascertain that it is in a particular state, like the pencil, like this? Quantum mechanics says you cannot tell until you interact with it, until you observe it. The reality is, according to quantum physics, is a combination of all the possible states in which it can exist. It's a very crucial idea. If next time anybody asks, this is the most crucial idea. When you think of microscopic objects, not you and me, not even pencils, microscopic objects, the reality consists of all possible states in which it can exist or we can imagine.
Is this like the observer experiment that they present in what, the bleep?
I'll come to the bleep. Now let me formulate the question. You want to believe that the world exists like that? The much more dramatic way of presenting this situation. You may just believe what I said. But now hear this story. Instead of particle, let us trap a cat in the box. Put a poisonous gas there. At some point, Schrodinger's cat. Everybody heard about probably. You read this literature. Well, the poison is such as it may or it may not kill, depending upon how you shake it or whatever it is. But without opening the box, if you ask in what state the cat is, the quantum mechanics is telling, since you don't know whether the poison actually acted or not, it's a random procedure. We constructed this box. Imagine anything. At any given time, quantum physics says it is in a state of being dead plus being alive. How can one be in a state of being dead and being alive? Of course, it looks paradoxical when you talk of cats. But we firmly believe, when we talk of elementary particles, before we observe, they are in all possible states. So the reality which we have not perceived yet is something more complicated than what we think after we observing. Of course, after we observe, we know whether it is dead or alive. A theory itself doesn't even say what mathematical procedure tells it is dead or alive. All that it says is it's a 50% probable dead and 50% probable. Now that is the first important metaphysical inference that comes from quantum physics. Think of this world in which it exists in all possible states all the time. Do you believe in that? Macroscopically, we don't pretend that we pretend, or we know that there is an objective reality which all of us can agree. We don't have to see it. After I leave this room, the chairs will be here, some of you will be here. We think of a reality that can be agreed upon by all the people, all the human beings at least. Well, even if cats are here, they will also understand this. Now, this is the idea that is promoted mathematically to understand the microscopic world. Microscopic world, elementary particles. So now we can, based upon this, we can construct, add some assumptions and talk about what it might be about the whole universe. Okay? We talked about your being able to tell that it is horizontal after you look at it. Of course, we can also take a photograph, or a camera can take a picture, and tomorrow we can tell. We don't have to be here today. Tomorrow we can run back the film and say this one is horizontal. But ultimately, the metaphysical jump is your consciousness is involved in ascertaining what is the empirical reality is, I mean, observed reality is like. So, while quantum physics proposes this fascinating picture of all possible realities or a potential reality, the empirical reality which you observe needs an interaction. Let's put it word, why hide the truth? Consciousness. Your consciousness is not your consciousness and my consciousness. If you think of the whole universe, the interaction, this is the religious leap. Quantum physics doesn't say it, but we extend the idea to say maybe this empirical reality emerged, created because of the interaction between some collective consciousness with that potential reality, which is unknown to the extent that it is made up of all possibilities. So, from here to here, well, when you talk of these things, what we have emerged is, religiously speaking, sometimes we talk of how the world is created. This arrow can represent the process of creation for us, which needs these two aspects already buried in this potential reality. Of course, you can give lots of names to this. You can call it God, Brahman, or some super consciousness. Do you have any other names to suggest of that category? We can think of it that way. So now I have found, even though my quantum physics is basically designed to study the behavior of the particles by extending the ideas that are buried in the formalism, I was able to connect, just hope, maybe this universe is actually, what did you say? Observer effect. Because I think it's, if you say, but then to go to the extent of saying, I create my reality, it's a kind of a invasion of privacy, but whether it is true or not, we don't know. Maybe you are playing with words.
Egocentric a little bit. Egocentric a little bit.
Yes, well, leave all those people, we call them quantum spiritualists at the end. Different people have interpreted the formalism, the power of the formalism in different ways. This is the first important idea I want you to carry. What we know about the physical world, knowing all the rules of the game, we extended the idea in a metaphorical way to think of the large-scale universe, or even the beginning of the universe, in terms of a consciousness-like thing, important in separating empirical reality, that which we observed, from the potential reality. So, isn't it good to know what this super consciousness is? I mean, isn't it a good adventure to find out what it is? Of course, we admit that we possess something of that kind in our own mind. Our mind is conscious, otherwise it is a useless thing. I take my nails off every week. I don't care, they don't carry any consciousness. But I have a mind which is conscious, which is aware, which is formulating all these theories, making me talk to you. Each one of us have. That may be carrying the essence of the consciousness that is involved in the very beginning of this creation, if you want to think like that way. See how far I have gone spiritualizing my ideas of quantum physics already. I want to leave some time for you to ask questions, but let me take one other aspect of the quantum physics. The latter, yes.
You have at least until quarter two.
Good. In the latter half of the 20th century, a very significant discovery was made. Again, because of the work of quantum physicists, let us say. People think of it as the most important aspect of the physical universe that we have learned. That is, imagine two objects joined together, spent some time together, interacted with each other, and they got separated, like a married couple who divorced. And according to laws of physics, we can say if two particles got separated, there are laws of physics which exactly tell which way it goes, which way it goes. They go far away from each other. Our general concept of the reality is, once they got separated away, They act like independent objects. Doesn't care what happens to this or what happens to that. That's our common sense view of the macroscopic world. What we found, both by implication of the quantum physics theory, I wouldn't want to go into the theoretical thing for you. Quantum physics implies that. Actually, in 1935, Schrödinger wrote actually a paragraph saying, if such a system exists, there are always plenty of them, and then they're separated, you cannot describe them as independent objects. You have to always consider them as two connected objects. There is some connection between them which you can never break. It is experimentally proved and theoretically postulated, quantum physics. You know the implications of this. Now that we are here together, spend 40 minutes, for the rest of our life we are connected. You may be coming in my dreams, I don't know. This is a unbreakable connection. It's forever. And not just 20 miles away or 30 miles away, according to our estimations or projections. Even if you go to the end of the universe, the connection is not being broken. This, now in the literature, this word, if you Google this word, you will find non-locality. That's more a trade language. More popular language, entanglement. Once they are entangled, they are forever partners of a joint system, not individual. See, Einstein has a difficulty accepting this kind of a thing. So he used to make all kinds of jokes and come up with questions. But his own questions gave way to formulations of the theory in a careful way, and experiments were done over a period of 20 years, starting from 80s up to all late as 1999. In entangled pairs creation is a big industry now. We are thinking, our scientists are thinking, they may be used construct what might call quantum computers. So it's real stuff. Well, what does this mean to us? Add this to this scheme, which I just made up. You don't have to believe in what I said, but this empirical reality is not objective reality. That means each object being independent, but connected reality, entangled reality. If you were to believe in Big Bang theory, let's say, anybody heard of the Big Bang theory? That all our universe might have come up 13.7 billion years, 13.72 billion years ago. We were all at one place, not we, our constituents, those that were created, those that were there, maybe it's all in the energy form. Well, it got separated. So now we say each part is somehow connected with the other part. And the catch is this. It's not easy to find out this entanglement. The experiments have to be done so carefully that you just don't see them obviously. You have to be very, very careful, remove all other possible interactions so that nothing can disturb the system, and then you will actually find proof for the entanglement. So it's a very delicate thing. In this universe, even though we believe we are all interconnected at a microscopic level, it doesn't manifest every day. You don't find, there's no shock when I shake hands with him. No particular thing happens. We act like independent objects. But in the essential bottom, we are part of a large whole, not emptiness, big thing, which parts are interconnected, related to each other. Well, Obviously, he is the whole. You want to use the word God. The Hindus use the word Brahman, out of which everything comes, dribbles out. Of course, that's a top-down creation. But they can boast that quantum physics is also converging towards such a thought. And even monotheists can claim. All religious traditions can claim this as consistent with their own tradition. If you are an atheist, you are still in good shape. You can believe in these things. But the goal would be, what is the best thing you can do in your life besides doing a job, having parties and vacations and all those things? To know the true nature of yourself. And if the true nature of yourself is described in this way, you better find a good way to do it. And of course, one of the age-old tradition is, you seek through your mind, use your mind, because that is the only one seems to have anything that can be directly connected to the so-called universal consciousness or Brahman or God or whole. So with that, once you made up all these things, and if your empirical reality is connected with the quantum physics understanding, if you believe in this, you become a quantum spiritualist. Just a code word people use. So that's where the physics we learn gives us an opportunity to speculate about our existence in a much broader sense. Besides knowing actually what is there, the Large Hadron Collider in Switzerland is going to search for particles that might have been there in the very beginning. But of course we don't know if they're around. You can say that is my ultimate goal, but now you can take this metaphysical excursion and talk about the reality and the nature of ourselves and hope that we can learn, if we believe in this, something more. I'm not claiming I believe in this. I just want to tell you, when we learn quantum physics, there are essential features of it that can lead you to these conclusions if you add some assumptions. Like the universal consciousness, you have to add additional assumptions to the knowledge you gain to connect it to our traditional views. Okay? I think you should ask questions. Yes?
But isn't everything entangled ultimately? Because, we talk about the one, the foundation of everything. So isn't everything ultimately entangled anyway?
Well, that's the position you are coming from. You postulated it as a most useful way of looking at the world. And here I am saying quantum physics also gives us a hint that it might be. So you are agreeing with this, science is agreeing with the traditional view, provided of course you have to add these additional assumptions. But there are people who believe scientific materialism. They wouldn't even worry about this business. This is all just a mathematical scheme. World is made up of matter. If you are conscious, it came out as a bonus, emergent phenomenon. So there are people who don't think like. But if you start with the assumption of oneness, this will provide you a supporting knowledge. So it agrees with it. You might probably are asking, what is new about this? It's not that is new about it. What is new about it is we understand the empirical reality much better. We make predictions, we make inventions, we may improve our lifestyle and all those things. But 100 years ago, if you just sit there thinking of one, yeah, it didn't help very much just thinking about it. Collectively, this society, it might have improved the state of mind of an individual being, but this society has not benefited from an individual's progress. So now we might think that idea, reinforced with this science, is actually a good idea, and there is hope for us. That's what I think. Yes?
Would you say that most physicists today believe in a universal consciousness?
No.
Would you repeat that?
Would you?
Oh,
No,
Yeah.
no.
okay.
You're
Most modern-day physicists believe in universal consciousness.
Do most modern day physicists subscribe to the idea of universal consciousness? No, I don't guarantee that. Most of them do their day-to-day work of using quantum mechanics to understand the matter. Yeah, the philosophically minded, the religious, spiritually minded will ask questions, but they have different kind of answers. This is one kind of answer. It is not a given. There are different ways of approaching this. In fact, as I said, there are people who don't even need to use this idea. They just start with this idea. The scientific materialists simply think, yeah, the world came into existence in the form of some energy and out came matter. If you ask question why, we don't know. It just happened. And they're happy with that. But so there are different kinds of opinions, but the majority are not into this game. Majority are busy working, learning. We don't even talk about this in school unless they take a special course, like which I am talking. Even there, I carefully tell them there are different ways of looking at it. I wouldn't tell them that there is a universal consciousness and go and find it. Yes.
Some of these esoteric teachings say that all time and everything exists all at once. Would that potential reality link into that?
Well, there is a general theory of relativity by Einstein, which concerned itself with the nature of time. So there is always this question, is there absolute time that exists in which we are moving? Since Newton's days. But when Einstein came along, he said, this time which you are talking about, the clock time which you are talking about, can be different for different situations. If you are moving with a high speed, your second will be of different duration than the person who is not moving. So talking about absolute time, according to him, is unnecessary and meaningless in order to understand the physical world. The quantum physics has to be coupled with that idea, special theory of relativity we call it, in order to actually understand. The advanced version of quantum physics includes that concept. So even though until Newton time, until 1900, we believed in the idea of absolute time, some eternity existing, we, in terms of understanding the physics, we abandoned it. Not that we say it doesn't concern us. To study the physics, we don't have to subscribe to such an idea. Now, if absolute time, does it exist? If your faith says it exists, go ahead and believe in it. But as far as physics is concerned, we don't have to think about that. It's an interesting departure from what we might usually think. The other way of putting it is there a beginning for the time? Okay? So according to general theory of relativity, the time is born at the time of Big Bang. Space itself is born at the time of Big Bang. Space itself is not an ordinary empty space. It's a dynamic quantity which is stretching and stretching and stretching and stretching and stretching. That's why we see we see the apparent motion of the galaxies running away from each other. Not that they're running away, the space between them is stretching. So these look like crazy ideas, but that's what the physicists adopt now. Yes?
Blavatsky in the Theosophical Society refers to this potential reality with the term monad, which she gets from Leibniz, I'm assuming, because Leibniz predates her. So my question to you as an expert, probably knows more about Leibniz than I do, is what's the mathematical and physics definition of Leibniz's theory, and why do you think she possibly would use that to refer to the potential reality?
Well, Leibniz wrote so many things. I'm not an expert in what actually he wrote.
Okay.
But remember, this is a concept that I presented to you from the point of view of quantum physics. But the idea that everything that we see exists all the time is from an ancient tradition, and Leibniz might have contributed to it. I must profess my ignorance of. I know him as a good person who wrote calculus and all those things. His philosophical writings I'm not familiar, but I would attribute this to the ancient tradition in which people speculate about time. What do you mean by eternity? So you can't go back in time and say this is the beginning. You can't go forward and estimate this would be the end. And that has been one particular thought that pervaded our discussions, with the idea that the universe existed all the time. Did God in a particular instant create it, or it always existed? Those are the kind of questions we speculated. We did not have answers. Only in the 20th century we got a handle on what we call duration, interval of time, clock time. That it is different for different people. In fact, it is different whether you are on the Earth's surface or a moon's surface or a Jupiter's surface, depends upon the gravitational force where you are.
It seems that quantum physics tells us that we create reality. That just as in Schrodinger's cat, it's not only what we see, but our intention creates reality. Is that?
Now that is a phrase which is misused.
Okay.
When we say potential reality, you are not creating reality, you are discovering the reality. The word creating the reality is an unnecessary extrapolation, which modern day quantum spiritualists make use of it. It is not part of what it says is, in order to actually find out the truth, you have to have interaction. When there is interaction, you know exactly what it is. Now, if you subscribe to the instead of potential, that's absolute reality. That is being in a superposition. Your interaction did something to it and produced the empirical reality. See, the assumption has to be different.
So it's singled out a reality.
Singled out that is not the whole reality. We encounter reality through our interaction. The question usually our people ask is the moon there when we are not looking at it? It is there. But then we invent all kinds of arguments to say it is there, even though you are not interacting with it. So don't elevate yourself to such a grand stage that you are the creator in the universe. In some sense, we are co-creators. We create things. Somebody created a chalk piece. Somebody invented a microscope. So many human beings are involved in creating new things in the universe. As you look around, everything almost is man-made, what you say. So in that sense, we are creators, but not in the sense of creating reality out of nothing. Even then, unless you subscribe to the idea that there is an absolute reality, of course that's what these religious traditions have done to us. They have created for us an absolute reality out of which we have emerged through some, like I say, as a Hindu I would say through Maya or the power of Ishvara. This world is created and created me. Why did he create me? So that I can be a partner in his scheme. Not just sit dead like a petrified wood. He wanted me to participate. There is no option according to Bhagavad Gita to be idle. Everybody should be acting all the time. And he prescribed how we have to act so that others can benefit from your existence. Always perform actions that are good for others, that create happiness for others. Of course, he warned other things. Anyway, we're going far off the subject.
So if, in terms of the creating, if the reality is here, that potential, that absolute reality, and if I look at it from this direction or from that reaction, I will actually be seeing something different.
But you are not outside this reality.
No, but
See,
that
the
if I
entanglement,
if
tells
I
you.
interact with it in a different manner than somebody else, I see something different.
Different, yes, it is possible. But then, in the macroscopic world, we're talking about the elementary particles. In the macroscopic world, everybody sees the same chair.
Right.
You don't come up with a different chair here. You have not created the chair. So there is a level at which this creating interaction or discovering interaction is limited or similar to every other. Why is it similar to other? Come back to that. Everybody has the same kind of consciousness. Why everybody has the same kind of consciousness? They emerged out of the same kind of consciousness. See, this kind of looks like a circular argument, but a consistent argument. Why should I be thinking just like him or others? Because we have the consciousness. We have the consciousness that probably has an origin in something very common. That's why you use the word universal consciousness. Yes.
Can a physicist explain synchronicity?
No. He recognizes synchronicity.
He recognizes it?
Recognizes synchronicity, yeah. It is there. You ask him, it happens. So there is a room for physicists recognizes the what we call chance element in the universe. That things happen without particular order or things like that. Chance. And there is order, of course, there is a cause and all those things. In fact, we teach our kids so-called second law of thermodynamics, which simply says what you said. Things happen by chance. When things happen by chance, there can be coincidences. Now, as a religious person,
No, we got 1 minute.
we may postulate some power or something that exists to produce the synchronicity. But if you can't use it, what good it is anyway?
Thank you, Dr.
Yes.
What is considered virgin territory for physicists now? Where they could, their direction in exploring, but which direction are they headed in?
Well, there are a group of high energy physicists who are investigating the nature of the fundamental constituents. And according to the theories, in order to explain the behavior of fundamental particles, physicists postulated certain particles the name Higgs boson, some even call it God particle. If at the CERN labs, the Large Hadron Collider, if they can find a Higgs boson, that will set a lot of minds at ease. The theories are dependent upon. Of course, even if you do not observe, this will continue to play its role. Some of the things which I said were practiced for 80 years even before experiments confirmed the ideas. So that's understanding the fundamental interactions is one. Now, of course, as a practicing physicist, people are interested in mathematically describing several areas, levels of physics, and studying at the size of a few atoms, because you had nanotechnology, nanoscience, nanosecond, how objects behave of that size. This is bigger than the elementary particles we talked about. But then they are involved in our everyday activities and things that we want to make and things like that. That would be where a lot of people will spend maybe more people will spend their time studying. Of course, a physics community, everybody is looking for opportunities to discover something new. So whenever they encounter an unfinished problem, that's what to start looking at it. When graduate students come, they come to a particular research scholar in the area of research he is doing. They will discover questions to be answered, and then let's go on. But they're fashionable discussions. So your question is, what is the fashion today? So studying the fundamental interactions and the nano size materials. We think there can be something really valuable that can be harnessed if we know the nanotechnology. It helps us now miniaturizing everything. See, instead of huge computers, when I first became a graduate student here, which occupied a whole room, you have no computers in your little hand. So miniaturizing is a very important goal that we are talking about. So these are the areas I would think. Yeah. Yes.
Well, today, how relevant is the string theory still?
Oh, it is a, yeah. How relevant is the string theory now? Okay. Now there are people who are claiming string theory has not yet produced useful results. But that is the only theory that remained at this point to understand the basic interactions. It has not yet come up with the results that can be verified in an experimental situation. If not in the form in which we know, in some other form it will be very useful for us. It trains a lot of our physicists with using different mathematical techniques. When you say how relevant it is not removed from the agenda. Everybody is seriously. But there are people who have been writing books saying string theory has lost its power. If you come up with a solutions like that, an infinite number of them, what good it is? You have to know what the world is actually like. So that's where we are. It is a powerful theory. To think of elementary particles as not little points, but as little strings. And they solve a lot of conceptual problems. But we have not yielded yet a solution that can be verified in the laboratory. But there people claim it is a possibility. Yes.
Can you describe for the layman what the dimensions beyond the 4 look like?
Yeah. Okay. Well, I haven't seen them.
Oh, shucks.
Okay. Now let's see. When you say 4 dimensions, you are saying 3 space dimensions, which we need 3 dimensions. We live in a 3-dimensional world. In fact, physicists can prove that world has to be, physical space has to be a 3-dimensional world. And of course, time is additional, 4th dimension. But now we are talking of 6 more additional space-like dimensions. So one concept is what you think is a point. You put a point there. You think of it as no dimensions at all. But if your mind can peer through, it is probably a 6-dimensional world. Possibility. We don't know how to By analogy, let us say you take a hose, water hose, a pipe. Now, if you get closer, you know it is an object with 3 dimensions. Go far, 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 far away from it, it just looks like a single line, one-dimensional object. So we, with our macroscopic experience, not able to see, but maybe. But this could be only a mathematical scheme to understand the world, not reality. That's what quantum physics used to be. That infinite number of possible solutions is just a mathematical scheme and not reality. Schrödinger's cat assumes that it is a reality. What if it is just a mathematical scheme, not reality? Yeah, you can use mathematics to get all kinds of things. So you have 2 points of view. These 6 dimensions, are they really physical? Or are they mathematically you need them to write better, understand the situation better? People who claim that it could be real. So the one simple example I gave you is you probably cannot see the macroscopic world, but there could be more complicated structures. There's another possibility. We may be living in a 4-dimensional world, 4-dimensional space, not time. How can you think of a 4-dimensional space unless you go out of it? You can't see this 3-dimensional space as a separate thing. But what if? What if? How large it is? Again, it's a mathematical idea. Probably you have read a little when you were kids. Have you ever read a little novel called A Wrinkle in Time or something?
Yes.
At least one. That assumes a 4-dimensional world in which you go in and out to different spaces through your 4th dimension. It is a possibility that there is a dimension. Our world is simply a little surface in that 4-dimensional world. In fact, the idea of Big Bang is maybe 2 3-dimensional surfaces, if you want to call them, clashed with each other and out comes the Big Bang. So these are crazy ideas, look like that. But it's not easy to visualize, but it mathematically can be constructed. Yes?
What do physicists think, or do they ever contemplate about unexplainable things like telepathy and clairvoyance and that sort of thing? Do they have any explanation, or do they just sort of scream and run out of the room?
Well, remember, physicists are busy doing what they are experts in. Okay? What they are experts, what their skills are, studying it. Now, is there evidence for telepathy? If there is actual evidence for telepathy, they might seriously think about it. But people deny even the existence of what we call telepathy. So take the safe route of that's all somebody's dream. Yeah. So a practicing physicist is not deeply committed to that. But nowadays we are talking about quantum telepathy. Quantum telepathy means, see, when you say telepathy, what does it mean? You can send a message to somebody and affect that. Remember, it's an entangled system. What if you are able to send the messages? But now we are finding an interesting trick. You produce an entangled pair from an already existing entangled pair, and if you do something to one of the partners of one pair, that information must reflect in another pair. So you may be able to actually transfer information to the other person, not by postman or by signals, by just working with the entangled pairs. And they will call it figuratively quantum telepathy. That's as far as we can go.
That's why the leading edge of the study of psychic and telepathy is coming from twins, the study of twins, because they're more quantum entangled because they actually they were one cell that separated
Oh, you're talking identical.
Identical twins, right.
But
So-
extending any of these, even the quantum telepathy, extending that to macroscopic systems like human beings is a leap in faith. So they don't have any means to work with it. Yeah, of course, others are better equipped because if they study the twins or some other situations. But as far as we go, ability to transfer. That means if you have that information, you can reconstruct this object there. So instead of actually physically moving, you have reconstructed this object there. And that's one of the, I read somewhere in the United States Defense Department spends a lot of money to make use of entanglement.
So that's essentially how it's, at least they're moving in that direction to explain it as part of this entanglement.
Right. A lot of literature on entanglement. Books are written. Yes.
Would you say that around the world physicists are working and sharing knowledge, or are the United States physicists hoarding their knowledge and the Soviets doing theirs and somebody else is doing
There
theirs?
is, on large scale, there's always sharing. Lots of conferences, you go there and projects are global actually. People from here go and work in Switzerland, they come to Fermilab and work. Yes, but then always the areas in which you want to preserve the right for discovering that. So there are areas in which people don't share information. Years later you find out. So, suppose, especially if an intelligence department or a defense department involved, you can't even squeal a word about it to anybody while you are working on that project. So there are people who, government-sponsored research may contain secret cabins and cells. But we think of science is an activity of a community of scientists who are open-minded in this sense. Think of every possibilities. Now, are they open-minded to share everything with everybody? It's a matter of individuals. Now, when do you share? When you believe what you have done is finally good. Until then, it remains your private property. Don't go around and tell. My advisor used to tell me a story. He was some physicists were traveling in an aeroplane, and two of them were very hotly discussing about an experiment, how to do it. The scientist sitting behind quietly went home and performed the experiment for himself. And he got the credit. So all kinds of possible things can happen. But in general, the science that is not secretive or these things like that is shared by everybody. It's a common practice to share. Nowadays with the internet thing, as soon as you have an idea, you put it in because that already gives you the claim that you are the originator. So it involves the desire you have, the protection you want to have for discovering those things. That will never change. It was true in Newton's times, it was true nowadays. Yes.
Have you any thoughts about what the next means of projectile will be, the fuel for projecting something, whether it's cars or jets or what will be the means by which we will be able to move around?
I think the electricity would be the next thing we will do. We wouldn't be carrying a nuclear reactor to move around. We depend upon electrical phenomenon. So whatever kind of energy we have will have to eventually convert it into electricity and store in a battery and take it. Okay, that would be, if gas is not there, if you have batteries, you probably can. So we move towards very large use of electrical and magnetic phenomena.
So the potential has not yet been found. I mean, the
Exhausted.
of the potential is nowhere.
The For locomotion, for example, in space travel, you need something that keeps it going. So they're called ion forming engines, which again, it's electrical phenomena that is involved. But in our ordinary life, I think we will be actually converting ourselves into electricity-based mobility. We already do that many times. Yes.
Do you think there will be a time when we'll be able to find a free source, energy source?
There's a lot of energy all over the world. The water is a big source of energy.
No, I mean like free source, meaning something that anybody could, with the proper equipment, could just tap into.
You just said water.
But the point is, that we have to have the technology to harness the energy that is there.
Right.
We could not. So it's a matter of not so much the knowledge; it is the economics and the willingness and how many people want to use it and things like that. Wind power, for example, people would like to use it, but then today you find it is very costly to put a windmill every place, even though it's wind free. Solar energy is free, and probably that's where we also go. But again, solar energy will be converted into electrical energy, stored. So one of the research areas is to talk about when light falls upon something, how it creates energy that we can draft and use it. That's an industrially very useful thing. You have raised your hand.
Couple. One is I was going to mention cold fusion. Second, this is in the field of Indian Ganita Jyotish. Do you accept that Bhaskara used calculus in his Siddhanta Shiromani?
Well, I've not studied those texts, but they have ideas that could give rise to the modern day calculus. They have not developed those ideas, but they have hints of going in that direction. In a lifetime, they did a very good job of what they were doing. The first question, cold fusion, I don't think anybody puts their money on it. People don't think it's a process that we can, well, we have not been able to repeat, first of all, what one people claimed. But I don't see as a nuclear physicist possibility of cold fusion. What he is talking about is, in physics we think of when some elementary particles combine together into larger quantities, they release energy. In an ordinary reactor, when uranium atom breaks, it releases energy in the form of neutrons running around. In the fusion, to bring such two particles that close, because there are already interactions that, to bring them that close, we have to really raise it to very high temperatures. And that's why fusion reactions are studied in regimes where high temperatures are. So, but at cold temperatures, the possibility that two tiny little constituents will combine is so small, it's the chance of even, we can't say it never exists. Quantum mechanics says, yeah, there's a possibility for it. But it is not considered as a viable method to think about it. Yes.
What about Nikola Tesla? He had an idea of some source of energy, and I can't remember what he called it right now, but it's an energy field throughout the universe that we can tap into and actually draw energy from it.
Well, it's again a speculation. Having seen things being explained in terms of energy, where is the energy in this world? So postulating a field of energy in the universe is an idea. Now, if you ask somebody, what is here in this room? Is this space empty? Well, physicists don't think this space is empty. This space is full of electromagnetic fields which come out with the light. In fact, millions of neutrinos are flowing right through the room. We don't even know because they don't interact with us. So we are not in absolute emptiness. It is not nothing. It contains something. If you can cash in on that, it would be wonderful.
Sure would.
I mean, millions of neutrinos are going right through my hand, and they have no effect on this hand. But if only I can feel it, I can use it for different purposes. So again, interaction-based existence. Yes?
I heard some scientist was working on going down really far, far deep into the earth in a particular type of metal or that was in this particular portion of the earth that slowed down neutrinos enough that they could see them.
Well, there are deep mind experiments that were done. In fact, in 1987, one of those machines caught about 11 neutrinos that came from a supernova explosion, some 160,000 light years ago, something like that. Something happened, and now it took that much time to come, and we know when it happened. We know how long it will take for these to come. And when they did the experiment, they actually caught 11 neutrinos to confirm our understanding of how stars work and how the world is full of neutrinos. Of course, in a nuclear reactor, neutrinos are continuously produced, except we lose them. Neutrons, we catch them. Neutrinos, we lose them. So the reason for a deep mind, they want to avoid all other possible interactions, completely shield it away, and the detecting volume so large that if something happens, they can detect it. The probability of detecting it. Yeah. Yes.
All right, thank you, Dr. Rao. I was really fascinated by that.